listen to the sound of the ocean. It's beautiful.
Okay.
Here, you have a lesson.
Okay, that's cool. Do you know why it sounds like that?
Does it have something to do with the shed?
Yeah. Have you ever wondered why it's shaped like that, though?
No.
This shape is called a logarithmic spiral, which is a spiral whose equation is r is equal to a e to the b power times theta, where r is the distance from the origin, theta is the angle from the x-axis, and a and b are arbitrary constants. So logarithmic spirals can be found in seashells, and the formula is r is equal to a times e to the b times theta. And here, r is the radial distance, a and b are constants that set the dimensions of the spiral, and theta is the angle displaced along the spiral. So an example is Alice finds a pretty spiral seashell creature at the beach. She measures the distance between the first two loops of the spiral from the center and finds that they are 2 centimeters and 4 centimeters. The shell is not big enough to have a third loop, but she predicts in a few years the distance will be 8 centimeters along the same line. Okay, so when you solve for this, it's 2 pi per revolution, and the radius for the first loop is 2 centimeters, so it would be 2 pi. The radius for the second loop is 4 centimeters, so it would be 4 pi. We don't know the radius for the third loop yet, but it's 6 pi because it's 2 pi per revolution. The a and b in this formula are arbitrary positive constants. So the first loop is 2 is equal to a times e to the 2 pi b. The second loop is equal to 4 is equal to a times e to the 4 pi b. The ratio would be 4 over 2 is equal to a times e to the 4 pi b over a times e to the 2 pi b. Then you solve. 2 is equal to e to the 4 pi b over e to the 2 pi b, which gives you 2 is equal to e to the 2 pi b. Using the log rules we've learned, the next step would be natural log 2 is equal to 2 pi b. Then you divide both sides by 2 pi, which gives you about 0.1103. The second loop would be 4 is equal to a times e to the 0.1103 times 4 pi, which would be equal to a times e to the 1.3863. For the third loop, the equation is r is equal to a times e to the 0.1103 times 6 pi, which is equal to a times e to the 2.0794. You have to take the ratio between the two equations for the next step, so it would look like r over 4 is equal to a times e to the 2.0794 over a times e to the 1.3863. You multiply both sides by 4 and you get e to the 2.0794 over e to the 1.3863, which is approximately 8 over 4, which would equal to 2. So the radius would be 4 times 2, which is 8.
Okay. Well, you're bad at it. I'm gonna go play some guitar.
Okay. Hey.
Hey guys, what you doing?
Just jamming.
You know, logs have a big part in music.
Yeah, I'm interested. Please tell me more.
Sure. You know that notes played together either sound good or they sound really sucky?
Yeah.
Alright, so they sound good because the frequencies match up. An octave is basically doubling the frequency, and you can use logs to find the frequency of each note. Hey, Carol! Hey, what's up?
So.
You know, computer applications use logs too. Yeah, many programming languages use logarithmic functions to establish nonlinear relationships and to define inputs into calculations, you know? And for example, logarithmic functions used to calculate real arguments outputs in a computer program must be greater than 0. Okay, so people at the morgue use natural logs, and the first problem we're going to look at deals with dead bodies. And so a dead body decays at a rate of 0.02% every hour. After how long will half of the body be remaining? And the formula we're going to be using is y equals n times e to the negative kt. So k is the rate of decay and n is the initial amount. So first, we're going to write this out in context of our problem. So y is going to be 0.5 because that would be half of the body. and n is 1 because we're starting out with the whole body, and k is 0.02 because that's how fast the body decays every hour. So it's 0.5 equals 1 times e to the negative 0.02 t, and then we can just take out the 1, so it's 0.05 equals e to the negative 0.02 t. So you write it in natural log notation. So it's natural log 0.5 equals negative 0.02 t. And you plug everything into your calculator, and you get t as 34.657 hours. So the answer to the problem is that after 34.657 hours, half of the body will be left. Scientists studying bacteria use the exponential growth formula, which is y equals n times e to the kt, and the k is positive this time. The variables stand for the same things that they did in the previous problem of exponential decay. So there are 5 bacteria that double every hour. After how long will the population of the bacteria be at 25,000? So we're going to use our formula y equals n times e to the kt. So 25,000 equals 5 times e to the 2t. And then we divide both sides by 5, so you get 5,000 equals e to the power of 2t. And then you write it in natural log notation. So natural log 5,000, and the base is obviously e, equals 2t. And then you plug it into your calculator, and you get t is about 4.26 hours.
I got a little song for you guys.
When we learned love the first time, singing how they were so hard. Cause like we didn't understand what's going on when you said we had a test.
What?
Then we looked at all them logs and said,
Why even care about this? Cause I
remember how we got it for a day.
I say, I hate you, screw this, we're going on Facebook.
Sonny comes over at lunch and says, hey guys, I'm telling you, logs are used in application. Logs are used in situations. You look at dead bodies and deliver baby soup. But logs are used in every nation.